Depending on your knowledge of this topic, the question, what's the difference between Unicode and UTF-8, triggers two distinct kinds of emotional response. Before you click away thinking, I know this one already, in part 1 of this video, I'll make an honest attempt at answering this question. After that, I'll tell you why I think this question is legitimately confusing. So stay tuned. We probably all have the intuition that Unicode is about characters from all over the world. So let's start by staring at the English, German, and French alphabet for a second. Okay, now quick. What characters are in all three of these languages? One obvious answer is this. They share some letters and not the rest. Side note, I know this character is common between German and French, but I separate them here to avoid making a row just for it. Let's pretend this is right. Obviously, we also write numbers down, so let's add those in the table. Next, let's try to include East Asian languages. These languages have tens of thousands of characters, so we'll have to skip a few. Here, I include the characters from 1 through 6 in both simplified Chinese and Japanese kanji. In our big beautiful world, there are many other languages with written forms. If I skipped your favorite, my apologies. Just imagine all of them are in this table as well. And finally, the pillar of modern communication, emojis. A collection of characters like this is a so-called character set. Unicode, among other things, is an evolving character set that aims to cover all written forms of languages, emojis included. We'll refer to character sets with this diagram in the rest of this video. So far, we're just talking about natural languages and not computer programming. That is the proper realm to think about Unicode. But to understand UTF-8, we will now switch from human languages to computer languages. No, not computer programming languages. Those are for humans. Computers process and store everything in binary numbers, or bytes. Chances are you haven't thought about the fact that computers at their early days weren't invented for representing human languages at all. But not long after their invention, they'd gained enough computing powers to spare for that purpose. To represent characters in human languages in computers, we must decide what binary number means what characters in our set. Once this exercise is done, we'll get a map from some binary to each of the character. This map is a so-called encoding. Here's another way to think about this. For each character in our character set, we pick a sequence of bytes in computers to uniquely represent it. This fits perfectly in the definition of a function in mathematics. The encoding is a function f, the computer language or bytes is the input x, and the output is human language y. UTF-8 is one of such mappings we invented throughout the world and history of computing. By the way, not every encoding maps to Unicode. Most programmers have heard of ASCII. By now, we have enough knowledge to observe that ASCII is both a character set and an encoding. In fact, a table like this is another way to represent a function in mathematics. As you may notice, this is a very small character set compared to the one we started with. Just to round it out, here's another encoding GB18030 that covers all characters in Unicode. But as you can see in our example, it uses different byte sequences. I used this little Python 3 code to get the bytes. Just plugging the characters and encoding, and out comes the binary values. So that's the difference, or rather relation, between Unicode and UTF-8. I think if you remember the fact that we use a map from computer bytes to human language characters, it shouldn't be too hard to reconstruct this picture. This is a good time to admit, growing up, I myself had these concepts confused for a long time. I would look it up, understand enough to finish whatever programming task I was working on, and some amount of time later, I would promptly forget everything I learned. It took many such attempts for the concepts to finally stick. So why indeed are these things so hard to learn, even for some of us who does problem solving for a living? The following is a bunch of guesses based on my own experience. When I search up terms such as Unicode, I see a whole mess of concepts and their related terminologies. Turns out, the totality of human writing systems and our history of trying to cover them with technology is a perfect breeding ground for complexity. Meanwhile, all I wanted to find out is why my text is not rendered correctly on my version of OS, running a browser, showing a web page rendered by my backend code, fetching data from a particular database. Hopefully you can relate to what I'm saying here. There's a lot of inherent complexity in this space. Sure, with enough patience and learning techniques, all this knowledge can be learned or triaged, but failure in doing so again and again left me a level of fear and intimidation that I suspect subconsciously pushed me away from this topic as much as possible. Next, when I learned programming, I was taught that texts are represented by characters and strings, and only way down the line did I find out this so-called character and string value is not adequate in a lot of places. At this point, non-ASCII string values become something to deal with only when I have to. And how does one deal with those? Oh, my years of research tells me everyone is using UTF-8 everywhere now. Or is it Unicode? Or is that something we left behind? In my mind, these two terms are both associated with international language supports, and in my day-to-day programming life, I rarely think about them beyond that. Next, let's go back here. I want to talk about one of these terms, code points. Even though we call Unicode a character set, to make use of its collection of characters, we actually need to assign each of them a numeric value. We can roughly think of this value as a character's position in this big list.
These numbers are called code points.
And encoding like UTF-8 in practice maps from some number to some other numbers. This sometimes manifests itself to me as an end user. In a lot of places, you can directly put in this Unicode code points and get the character to show up. So you build an intuition where each character is associated with a number. Except for programmers, there's another number associated with the text, the bytes. Unless you already have a firm grasp on what we talked about in part 1, this can be confusing. Incidentally, translating Unicode code points to binary is called encoding, and the inverse is decoding. But as we have just established, both are translating from one number to another. So the implied directions in these words is really arbitrary. To make the matter worse, both of these actions are collectively referred to by the noun encoding, as opposed to some neutral terms like coding, codification, or something. This can be really irritating when you need something done in a pinch, like the Python script I showed earlier. Lastly, if you grew up using Windows and end up becoming a programmer, there's a high probability you've seen this piece of UI in the built-in app Notepad. Wait a minute, you can save the text as UTF-8 or Unicode? Okay. The young Daniel, curious and eager to soak up anything computer, burned this information in his impressionable mind years before he encountered these terms in programming. Little did he know this was a mistake made by the Windows UI designers, probably because their team is confused about this too. According to this Stack Overflow post by Bob, this so-called Unicode encoding is actually UTF-16LE or UTF-16 Little Endian. This mistake has been fixed in modern version of Windows, but I suspect it lived on in a non-trivial number of programmers' minds for a few generations. Okay. So that's the end of this video. Hopefully it cleared up some confusions on this topic for some of you, and for the rest, I hope part 2 provided some interesting perspective. And next time you ran into someone who are confused, you can understand their pain. Let me know in the comment your stories with Unicode and UTF-8.
And remember to give this video a like and subscribe to my channel. See you in the next one.